In this video, we're going to be looking at sample spaces, but more as like a combination. So as we get, as we like maybe like flip a coin, or maybe we're trying to order some food or something, and we can list all our options and see what all our different possible combinations are. So to do that, we have this thing called a tree diagram. So a tree diagram lets us visualize all the possible combinations from our sample spaces. So tree diagram lets us visualize all the possible combinations from our sample spaces. So the first thing we're going to look at is if it's a single sample space. So if we're flipping a coin 3 times, we know that our first space, our first time, first flip, flip 1, we could get a heads or a tails. Then on my second flip, after I got a heads, I could get a heads or a tails again. And after I got a tails my first time, I could get a heads or a tails. So I flipped it once, and if I got a heads, my second flip, I could get a heads or a tails. If I flipped it the first time I got a tails, my second flip, I could get a heads or a tails. And then our third flip, we can get a heads or a tails, a heads or a tails, a heads or a tails, and we can get a heads or a tails. And this helps us really see all our different combinations. I could get heads, 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 or I could get heads, tails, heads, or I could get heads, heads, tails. So that's how we kind of read it. So I can go, oh, what if I flip the tails first? Well, then I could get tail, tail, tails, or I could get tail, head, head. So this just shows us all our different combinations. And when we get to the bottom of our tree, we can see our total amount of combinations. There are 1, 2, 3, 4, 5, 6, 7, 8 total combinations. That's what a tree diagram kind of helps us do. Helps us see all the possible combinations. And sometimes we have multiple sample spaces, such as if I'm trying to order a pizza. So let's see all our different combinations when I'm ordering a pizza. Well, I could start off with thin crust or hand tossed. And then thin crust, I could have pesto or red sauce. And the same with a hand toss. I could get pesto or a red sauce. And then if I want to just choose one topping, I could choose from the pesto, I can choose a pepperoni, I could choose bell peppers, or I could choose cheese. I'm going to abbreviate cheese so I have some space. And then with my red sauce, I could have the same thing. Pepperoni, bell pepper, or cheese. And the same thing with my hand tossed pizza. I could have a hand tossed pesto pizza that has pepperoni, bell pepper, or cheese. And I could have a hand tossed pizza with red sauce that could have pepperoni, bell pepper, or cheese. Sorry, I kind of ran out of space there. Maybe we'll put it on top. Like that. So now we can clearly see all our possibilities. I could have a thin crust with a red sauce and bell peppers, or I could have a hand toss with pesto and just cheese only. And this is just kind of like a visualization of all our possibilities. And then we can count up just by counting across the bottom to see all our possible combinations. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So we have 12 total combinations, possible combinations. But there's a shortcut if we want to just get to the total number of combinations instead of drawing all our. So this helps us see the combinations, but there's a shortcut to let us just find out how many there are. And that's going to be called the fundamental counting principle. And how the fundamental counting principle works is multiply the number of choices in each sample space together to find the total combinations. So let's say I'm looking for the fundamental, we'll call that FCP. Let's see, we can use the fundamental counting principle to verify our tree diagram. So how many options are there in my first sample space? Well, there's 2. And then how many options? So not how many that we see here, but what I'm really saying is if I flip a coin, I still only have 2 options. And if I flip a coin again, I only have 2 options. So I can say 2 times 2 times 2 is 2 times 2 times 2 equals 8. And there we go. Oh, look. So the fundamental counting principle lets me quickly find the total possible combinations. So in my sample space 1 over here, let's verify our pizza. There's 2 options. My sample space here, there's 2 options. And then my sample space for my toppings, there's 1, 2, 3 options. So now what I can say is using my fundamental counting principle, I can say 2 times 2 times 3, and that will equal 12. And then we can go, oh, look, I can draw my tree to see all the possible combinations, but I can use my fundamental counting principle to quickly find the total amount of possible combinations. So that is how we can use a tree diagram to represent our sample spaces and combinations, and also use the fundamental counting principle to quickly find the total. So thank you very much for watching this video, and I hope you have a great rest of your day.